Hello everybody. Welcome to review video number 1. So this one is for chapter 1 and we're going to be talking about measurement. We'll be talking about variables and we'll also be talking about statistical inferencing. So let's start with measurement. And in class we asked fundamentally what is research? And at the end of the day, research is if somebody has a question and they want that question answered about something in the world. They create something called a research question. So then the question becomes, how do we answer these research questions? Usually in quantitative statistics, we answer research questions by measuring things that we're interested in and then comparing these measurements to other measurements to see whether there's a difference or to see whether there's a change in these measurements over time. So like I said, for quantitative research, so we usually measure things and then we compare these measurements to other measurements. So when I say things, what do I actually mean by things? Well, if we break measurement down into two components, we can either measure something called variables, or we can measure something called constants. And what variables are, is it's a measurement that can assume more than one value. So basically a variable varies, meaning that it can change. So for example, if we're measuring something like height in centimeters, if we measure somebody's height when they're 1 year old, that height can change over time as they grow up. So height would be considered a variable in this specific situation. A constant, however, is a measurement that can only assume one value, so it never changes. So an example of a constant would be something like the speed of light, right? The speed of light is always constant. The speed of light never changes. Another constant example could be something like the number of baseball players on a baseball team. Okay, the number of baseball players on a baseball team on the diamond is always going to be 9. It's not going to change. It's not going to be 8. There's no modification for the game of baseball, so 9 is the constant. So we can break down variables further into two more components. So we can either have continuous variables or we can have discrete variables. What a continuous variable is it's a variable that can assume any value. So this includes decimals and continuous variables. So an example of a continuous variable would be something like time, right? So if we measure time, so let's suppose that our research question is how long in minutes and seconds does it take for a certain sample of people to run 100 meters, then time is our continuous variable. So people can run, let's say 13 seconds, but then somebody else can run 13 seconds and 1/5 of a second. So at any point during that continuum, somebody can fall on a value. So it can assume any value. The other thing to note here is that the continuous variable usually, let's take the example for 100 meters again. So if somebody runs a 10-second 100-meter dash, and then somebody runs a 20-second 100-meter dash, we can safely say that the person who ran the 10-second 100-meter dash was twice as fast as the one who ran the 20-second 100-meter dash. So it's equal spacing between the values. And we'll get a bit more into that when we talk about the scales coming up next. On the other hand, a discrete variable is a variable that is limited to certain values. Usually they're whole numbers, but they don't have to be, right? An example of this, and I feel like we've all seen this before, is the rating of perceived exertion scale. So if you think back to first year and you guys learned about the Borg scale ranging from 6 to 20, those are discrete variables, right? You show that scale to somebody who's exercising, and then they give you a number between 6 and 20. They can't give you a number lower, so let's say 4, because that's not part of the scale. They can't give you a number that's higher, so 22, because again, that's not in the scale. So the value that we get from the person who gives us the number is discrete. We can break it down further, and now we're having our scales, so our level of measurement. Usually, continuous variables and discrete variables can be broken down further. So if we start with discrete variables, we have our nominal scale and our ordinal scale. If we have our continuous variables, we can break it down into either interval scale or ratio scale. So let's take a look at each one of those. So when we're talking about the nominal scale, that means that it's a variable that is grouped into specific categories. So for example, if I was going around and asking people what their favorite color was, then that would be a nominal variable, because there would be a certain amount of people that would like blue best. There are a certain amount of people that would like green or red or pink, right? So those are names and they're categories that we're grouping people into. An ordinal scale is a variable that is ranked in order, but with no real indication of how much better one rank is than the other. Okay, so let's take an example of a Likert scale. So I don't know if you guys have ever done these surveys where it's asking you rate your favorite movies from a scale of 1 to 5. 1 being the worst movie you've ever seen, and 5 being the best movie you've ever seen, right? So it's a numerical value, and there's an order to it, so from 1 to 5. But who's to say that number 2, so if you give a value of 2 to a movie, who's to say that's twice as worse as a movie that you rank as 4, right? It doesn't work like that. So it doesn't tell us, okay, 4 is twice as much as 2, or 5 is 5 times as much as 1. That's not how an ordinal scale works, and that's not how a Likert scale works. So it's very subjective. If we think back to our example of the Borg's scale, so the rating of perceived exertion, that's an ordinal scale, right? So you have the discrete variables that are on an ordinal scale. So somebody gives you a rating of 11 at one point, and then 5 minutes later they give you a rating of 20, okay? That doesn't mean that proportionally they've increased the amount of work they've done by a, however much that is, like a 1.8 times scale. Hopefully that makes sense. So those are the scales that are used usually with discrete variables. Now, if we go into our continuous variable breakdown, we first have our interval scale. So again, this is a variable that is ranked in an order, just like ordinal scale, but this time it has an equal distance between the values. Okay, so for example, if we're measuring something like temperature, okay, if we have temperature and we measure the temperature at 2 different time points, and let's say the first time point it is 20 degrees, and then the second time it is 0 degrees, then we know that there's a 20-degree difference, and that there's a 20-degree difference, and that the second value is 20 times lower than the first value. However, with our example of temperature, it doesn't have an absolute 0, right? So 0 degrees, so if you take the value of 0, it doesn't actually mean that there's no temperature, right? There's still a temperature. If we go below 0 degrees, we still have temperature. It's just in the negative realm. So that's the difference between interval scale and ratio scale. So ratio scale still has a variable that is ranked in an order. It still has equal distance between values, but this time it has an absolute 0 value. So for example, if we go back to our height example, if you have a height of 0, you have no height, right? So if you're measuring somebody's height, it couldn't possibly be 0 or below 0 because that just doesn't make any logical sense. So usually when we're talking about quantitative statistics, we'll be using all of these different scales. But when we're talking about our variables that we're measuring and that we're interested in, we want to make sure that we're using either interval or ratio scale variables. And the reason for that is because when we do statistics, we have two types of statistics that we can run. So either non-parametric or parametric statistics. Okay. Parametric statistics are more complete and it assumes certain assumptions about the data. And we'll talk about what these assumptions are in a later chapter. But basically, ratio and interval scale variables meet certain assumptions so that we can go in and do some analyses with this data and then get some numbers, and we can compare different measurements. And that's what we started with at the very beginning. We want to measure things and then compare them. With discrete variables, or ordinal or nominal variables, we usually end up using non-parametric statistics. So they are kind of symmetrical to parametric statistics. So for example, if there is a specific technique that we use in the parametric system, then there is an equivalent analysis that we use as the synonym in the non-parametric system. Okay? But for non-parametric statistics, we don't necessarily have to meet certain assumptions. So usually they're not ideal for quantitative statistics. That's not to say that they're not valuable. They absolutely are, and they're used all the time, and we'll talk about some of them later on. But for our purposes in this course, we're going to be looking mostly at parametric statistics. So we'll be working mostly with ratio and interval scale variables. So that's how we would categorize variables into these different levels. With any variable, we can also break them down into independent and dependent variables. So what is an independent variable? Well, it's the variable that is controlled by the researcher, right? So this is like our, this is what we keep constant in a research question. Alternatively, we have the dependent variable, which is the variable that we want to measure by the researcher, or that is measured by the researcher, and it's usually influenced by the independent variable. So for example, if we have a research question about what is the influence of height on weight, then we can see here, okay, this researcher controlled for height, and that can be seen on the x-axis. So we have short group, medium group, and tall group. So we recruited people and we put them into these groups and we controlled their height. So that's our independent variable. And then we see, okay, based on the group that they're in, based on their height, how does weight change? So then we go in and we measure everybody's weight. And depending on their height, their weight is going to be influenced. So the weight is on the y-axis, and that's our dependent variable. But just because in this specific research question, height is the independent variable, doesn't mean that it's always going to be the independent variable. So if we have another question, and we ask what is the influence of calcium intake on somebody's height? In this research question, calcium intake is actually the independent variable, so we control for people's calcium levels. And then we see, okay, depending on how much calcium they're intaking, how does that influence their height? So in this situation, the height is actually our dependent variable. So moving forward to parameters and statistics. So when we're talking about statistical inferencing, we're still talking about research questions. So if we have a research question and we want to answer it, we're usually asking a research question about a whole population, and that's depicted on the left. So if we take everybody from the population of interest, so we take every single person in the population and we measure our dependent variable, regardless of what the research question is. If we measure our dependent variable for every single person, and then we summarize all that information and we come up with an average and all that stuff, then the numbers that we get is called a parameter. So we know exactly what that variable is for the whole population. But usually we don't have enough resources, or we don't have enough time or money to measure every single person in a population. So what we do is we take a sample from the population, and we usually get the sample in a randomized fashion. So we just randomly pick people from the population, and this is depicted on the right. So we take a sample and we measure the dependent variable, so our variable of interest. And the numbers that we get from that sample is called a statistic. And we use that statistic to kind of predict or estimate or generalize what the population parameter is. So in other words, we use the statistic from a sample to make an inference about the population parameter. Okay, and that's how research works. We take a sample from a population, we measure a bunch of things, we get some statistics from those measurements, and then we predict or we make an inference about what the actual population parameter is. Now, because we're only taking a sample, what this means is that there's usually going to be some inaccuracies, right? It doesn't represent everybody in the population. There's going to be some error because we don't have every single individual. And later on in other chapters, we'll talk about how we report what this error is, or what our confidence is that we are, right about our estimate for the population parameter.